This is the Mechanical Engineering CAD task for the Mechanical Design Challenge. So you have your excavator arm here on the front page. Going down, this is the Mechanical Design Challenge module. You're given 6 hours to complete this. You will be given the actuator drawing, which shows you some parts you'll need to model, the design criteria drawing, and you'll also be given all of the excavator arm parts and a couple of actuator parts. The scenario is that it's been decided for you to produce a fully functional excavator arm using pneumatic cylinders. These cylinders come in stroke sizes from 100 to 500 millimeters at 50 millimeter intervals. It is your job to calculate which strokes will be required to fulfill the criteria set out on the design criteria drawing and produce a fully functional CAD model. So task 1, you'll need to create a 3D exploded view assembly drawing of the 300 millimeter stroke cylinder. In this must be a parts list. So you'll be given 2 parts, and you will also be given this actuator drawing. So this shows you all the bits you'll need to model before, of course, you can assemble those and then do the explosion. After that, you will need to create an exploded view animation of the 300mm stroke cylinder to fulfill the following criteria. The cylinder must explode and then collapse. The parts must not clash and should follow a logical order. O-rings clashing is acceptable. Screw functionality should be shown, so that means the screws will need to be turning in the correct direction as they're coming out. The camera angle should be changed to focus on specific assembly functions. Task 3. You'll then need to produce an assembly drawing of the excavator arm assembly, including calculated cylinders. So that will be the cylinders you've chosen from the range of 100 to 500mm cylinders up here. And within this drawing you must have a parts list and balloons. Don't worry about ballooning the sub-assembly parts, just balloon the sub-assemblies. The calculated stroke size of all 3 cylinders must be indicated on the drawing. So that means the 3 that you have chosen need to be indicated by showing the dimension of their stroke. And then you need to put an overlay view of the final design, and it must show the excavator arm in the fully retracted position and the fully extended position. You will then need to produce an AVI file to demonstrate the full physical simulation of the final excavator arm assembly. Within this you must include a complete stroke of each cylinder, so you need to show every cylinder working. And by that we mean fully closed to fully open and then back to fully closed. And all moving parts must be visible. The output will be the software model parts, assemblies, drawing files and the AVI files. Cylinders are to be positioned centrally on fixing rods, and bearings and bushes are not required. Final animations may be rendered after the end of the 6-hour competition time, up to a maximum of 30 additional minutes. You can take some final prints at the end of the 6-hour competition time. Maximum of 2 test prints are allowed per drawing. Any missing information is to be completed at the competitor's discretion, and all files should be saved to a folder on your desktop with your full name. The marking scheme here, you have some objective and subjective marking. So for objective, you get 2.5 marks for the exploded view drawing of the actuator. You then get 3 marks for the animation of that exploding and collapsing. Now, if you notice here, there's a massive weighting on the excavator assembly drawing, so you need to spend a lot of time on that. You can see it's worth 14.5 marks. And then you get 1.5 objective marks for the excavator arm animation. You can then see you have 3.5 marks down here for subjective, so that'll be things like, have you used good camera angles, is it a professionally put together animation, are you showing all materials, textures, lighting styles, scene styles, that sort of thing. And that's the task overview.